In this video, we are going to discuss how to use the data from an experiment to answer the questions. So first part of the question is asking you, data from the experiment is shown in the table below. The reading on the balance was given in grams. Complete the last column of the table by converting reading on balance in grams to newtons. The first one is done for you. Now in question like this, they have not given you any rule. They have not specified a rule that you need to use to convert reading on balance from gram to force in Newton. But they have done the first one for you. So in order to determine how to calculate the rest of the quantities, you need to compare these two. And how do we compare them? We can just divide the two numbers here to find the multiplier. So I will divide my 0.014 with 1.40 to find the multiplier with which I will multiply each of the quantity. And when you do that, you get the number 0.01. So if I multiply each term on the reading on balance with 0.01, I will get the force in Newton. So for every number over here, when I multiply with 0.01, I get 0.0312, 0.0462, 0.0624, and 0.0739. If they do not give you the first value to make comparison, you can always use the relationship between force and mass to find it. We know that force is equal to m into g. So first, all of my reading on balance, which is in gram, I will convert to kilogram. To convert values from gram to kilogram, you have to divide your quantity with 1000. So my value of mass, I will divide these values with 1000 to get the answer in kilogram. Once you get that, I will multiply my mass with g to find force. And to make our calculation easier, the value of g we will take as 10 meter per second squared. It is usually 9.81, but to make our calculation easier, we will approximate it to 10. So you can find your force as m times g. M when converted to kilogram gives me this value, m over 1000 times g, which is 10. And when you cancel off the 0, or when you solve this number, you get m over 100. So each value of m mentioned here, if I divide each of these value by 100, I get my force, which is nothing but what we did in the first part. Dividing by 100 is similar to multiplying with 0.01, and that is what we did in the first part. So you can use any one of these analysis that fits best for you. Either you compare the two numbers over here to get the multiplier, or you use the relationship between force and mass to get your multiplier. The second part of the question wants you to plot a graph of force on wire versus the current through the wire and draw the line of best fit. Now graph must be of force versus current. So whichever quantity comes before the first quantity, that I will place on my y-axis, and whichever quantity comes after versus, that will go on the x-axis. What are the steps to plot a graph? The first thing you must do is add a title to your graph. I must name my graph. The name can be a simple expression of what they are asking you in the question. Here they asked me to plot force versus current, so I have written the name directly as force versus current. After you give a title to your graph, then you draw the axis. And when you draw the axis, ensure that you label the axis. When I label them, since force is on the y-axis, I write here force, notation of the force, and the unit of force. Same for current. Current is on the x-axis. I write current, notation of the current, and the unit of current. This is how you label your graph properly. After you label your axis, then you have to number them. You need to write numbers on your axis. Now, don't directly take values from your table and put it on your axis. When you number your axis, you need to make sure that they are evenly spaced, that these numbers are equidistant. We always start our axis from 0. And from 0, when you put the numbers on your axis, they must be evenly spaced. The difference of two consecutive numbers on the axis must be the same. So let's check our readings. The current here is very simple to plot because difference between the consecutive numbers in current is the same. When I take a difference of 2 and 1, it will give me 1. 3 and 2 will also be 1. 4 minus 3 will also be 1. And 5 minus 4 will also be 1. The difference between two consecutive numbers in current is the same. So when I'm writing the numbers on my x-axis, I can write them to be these numbers directly. So the numbers on x-axis will be starting from 0, 1, 2, 3, 4, 5, and so on. But when you look at the readings on the y-axis, you will notice that the difference between two consecutive numbers is not the same. Difference between 0.14 and 0.0312 will not be the same as difference between 0.0462 and 0.0312. So I cannot take these values and directly put on y-axis. I need to space them evenly. So how do you do that? I know I will start my graph from 0. Starting from 0, look at the maximum value in your table. My maximum value for force is 0.0739. I have to choose the range of my graph to include values that goes from 0 to 0.0739. So let me take my range from 0 to 0.08. When I put numbers from 0 to 0.08, it will include all the values given to me in the table. Now you can decide how you want to place this number in the graph. As long as the difference between two consecutive quantities are the same, it doesn't matter what scale you choose for your graph. So I can start from 0 and go as 0.01, 0.02, 0.03, and so on until 0.08. Or I can take a difference of 2 and start from 0, 0.02, 0.04, 0.06, and 0.08. I can choose whichever scale I want to number my axis. As long as the difference between the two consecutive numbers remain the same, it is okay to use whatever scale that fits your graph the best. So here for force, I have taken a scale of 2. Each unit over here is 0.02. So when I go up, you go from 0, 0.02, 0.04, 0.06, and 0.08. So now they are evenly spaced. This is the proper way of numbering your axis. After numbering the axis, you will plot the points. You compare the numbers on x-axis to that on the y-axis and plot this point. And after plotting the points, you draw the line of best fit. It's not necessary for the line of best fit to pass through all of your points. It should pass through either maximum of the points or it must be close to majority of the points. And it is okay if you have an outlier. Like I have this point that does not fit on my line of best fit. It's okay to ignore this point as long as my line of best fit is passing closer to maximum of the points. So this is the correct way. of plotting a graph. You must have a title, the axis must be labeled, number on the axis must be evenly spaced, and the line of best fit. Let's look at part 3 of the question. In part C, they are asking you, use the slope of line of best fit to calculate the magnitude of magnetic field strength. So here they want me to use the slope of line of best fit to find magnetic field B. Since they want me to use the slope, let us first find the slope. Then I will show you how to rearrange your term to find B. What is the rule for slope? We can find slope by using y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are any 2 points on your line of best fit. When you're taking the slope, take the slope of the line, not the numbers from your table. So sometimes if your line of best fit is not passing through any of the points, and when you are taking the slope, you must take the slope of the line, not from the points given in the table. Here, my line of best fit is passing through 2 points that I have in the table. So I will try to find slope from these 2 points to get an accurate result. So let me choose my x1, y1 as this point over here, which is 3 and 0.0462, whereas my x2, y2 will be this 4 and 0.0624. I will call this x1, y1, x2, y2. Let's calculate the slope using this. Y2 is 0.0624, y1 is 0.0462 divided by 4 minus 3, and that will give me my slope as 0.016 Newton per ampere. After I find my slope, I need to use this slope to calculate magnetic field strength. Now the relationship between current, force, and magnetic field strength is F equals ILB sine theta. If I take my theta to be 90, sine 90 will be 1. And I can just reduce this expression of F to ILB. We can rearrange this term to find B. B will be equal to F over divide by I and L here. Since I and L are multiplied to B, when I rearrange them to find B, I have to divide by them, I, L. So B is equal to F over IL. I need to find out of these terms, which of the following represents my slope. Only then I can use slope over here. So what is my slope? When we find slope, we take the change in y-axis over the change in x-axis. Along my y-axis, I have force, and along my x-axis, I have current. So this quantity F over I here is my slope. So I can write this F over I as slope, and we get the expression for magnetic field strength as slope over L. Now we substitute the value. The value of slope is 0.016. L in the table is 0.10. And when you solve this, you get the value of magnetic field as 0.16 Tesla. So this is how you use information in the graph to solve a problem. You may have to rearrange the terms in your equation, find out which term in the expression represents the slope, substitute that term as the slope, and then get your answer.